welcome to our video. So my name is Gigio Sinwa and I'm from Group 2. So today we will be talking about the experiment with the Marcet boiler. For today I will be starting off the presentation. So what is the purpose of this experiment? So this experiment has a purpose of observing the relationship between the pressure and temperature for saturated steam. So thermodynamic properties of a pure substance could be determined by two of the following characteristics. So these are temperature, pressure, volume, enthalpy, and so on. So these data characteristics can be obtained either from experiments or equations or using a bit of both. So among two thermodynamic properties that are easily measured are temperature and pressure. So relations between these properties could be expressed in the form of graphs and equations. Today we'll be using an equation which is known as the Clapeyron equation, and through our calculations we will see what is the relationship between the pressure and temperature for saturated steam. So this is the Clapeyron equation. So the Clapeyron equation goes by dt over dp saturated equals to T times Vg minus Vf. Vg stands for the volume of steam and Vf stands for the volume of water, and that is divided by Hf minus Hg, which is also Hfg, which is the heat dormant of vaporization. Hf stands for the enthalpy of water and Hg stands for the enthalpy of steam. So throughout our experiment we have calculated using this formula, and we have found different and various values for our results. So without further ado, I will pass this to the next presenter. Thank you.
Good day everyone, I am Keshwini Raghuraman. Today I will present about the apparatus and experimental procedure for this experiment. For the apparatus, we can refer to the diagram shown above there. According to the numbering, 1 is drain valve, 2 is heater, 3 is overflow valve, 4 is filler plug, 5 is safety valve, 6 is temperature sensor, 7 is manometer, 8 is boiler with the insulating jet cat, 9 is temperature gauge, 10 is heater switch, and 11 is the master switch. So these are the apparatus that are used to conduct our experiment. Therefore, now we will go to the experimental procedure. For the experimental procedure, we started off by opening the filler plug. Water was filled into the boiler. The overflow valve was made sure to be open, and the water was let to flow out from there when the boiler was full. The filler plug was closed back. The water in the boiler was heated with the overflow valves open. When the temperature reached about 97 to 100 degrees Celsius, the overflow valve was closed. The increase in temperature for each pressure of 0.5 bar was noted until the pressure reached 5 bars. The heating was switched off, and the decrease in temperature for each pressure of 0.5 bar was recorded, and the result obtained was recorded in the table.
Hi, my name is Muhammad Shafiq bin Muhammad Rafi, and I'm going to present the calculations and the result part. So first of all is the raw and data analysis. So this table shows all data from this Marcet boiler experiment. The dark gray in color show all the data obtained from the experiment, while the light gray in color shows all the data obtained by performing a simple calculation. P absolute is calculated using a formula of P absolute equal to P atmospheric plus P gauge, while the mean can be calculated by adding increasing pressure with the decreasing pressure and divide by 2. And the last but not least, the measured slope can be calculated either using dP over dP or dVg over Hfg. So this is the Overview of the Excel calculations. Basically, this Excel includes the experiment table, the additional table for calculation and interpolation, saturated water and steam table, and also the graph for temperature increasing and decreasing pressure. Moving on, we need to draw a graph of pressure in bar versus temperature in Celsius for the heating and cooling process. So the vertical axis will be the pressure, while the horizontal axis will be the temperature. So the first graph is for the heating process, where the slope of the graph is given by 0.1, positive 0.1. The second graph then is for the cooling process, where the slope of the graph is given by 0.097, positive 0.097. So next we need to calculate the value of dVg over HFG using table 2, saturated water and steam, and compare the slope of the graphs that we have obtained in the previous section. So basically in the previous section, we calculate it using a method of dt over dp. For example, temperature change dt, we use 136.75 minus 131.70, we get 5.05. Then pressure change dp, we use 3.5 bar minus 3.0 bar, we get 0.5 bar, which is equivalent to 50 kilopascal. Therefore, dt over dp is equal to 5.05 divided by 50. We obtain 0.101. For dVg over HFG, since the table 2 show 1 bar, 2 bar, 3 bar respectively, we need to do interpolation. So if we do the interpolation to obtain HFG at specific pressure, which is 1.5 bar, then we obtain HFG equal to 2230 kilojoule over kg. We also do the same interpolation for Vg at pressure 1.5 bar. We obtain Vg equal to 1.2898 meter cube per kg. Therefore, we use the dVg over HFG formula. We obtain 0.221. So this table shows the comparison where majority of the value obtained having no big difference to the value obtained by referring to the saturated water steam table. And also the further calculation were done using Excel. That's all from me.
So I'm going to talk about the discussion. Two curve graphs of heating and cooling process were plotted, and the reading showed that temperature of water was initially at room temperature before the experiment started. So after we start the experiment, we noticed that the pressure increased with the temperature. So this can be explained by the relation between pressure and temperature of the relation P against T. For both graph 1 and graph 2, we noticed that the form of curves of both plots were quite similar, and this is due to the decreasing rate of temperature during the cooling process. So it is about the same as increasing rate of temperature during the heating process as well. So other than that, it is observed that the cooling process needed more time, as we all know that water cooling is slower than heating the water up. This is because we let the water cool down under room temperature initially, with no presence of catalyst to fasten the process of cooling. So the conclusion is, from the experiment, pressure and temperature of saturated steam are dependent of each other. It can be concluded when the water is heated, the pressure increases as the saturated steam temperature increases. Secondly, when pressure in the Marcet boiler is closed, the saturated steam temperature is being led to decrease as well. Thirdly, pressure is directly proportional with the saturated steam temperature. So lastly, the slight difference between the result and theoretical value is due to the slope of the curve graphs of V against T. This is because some errors are possible to happen during the conduction of this experiment. However, the difference is still small and it is still negligible. Thus, the objective of this experiment is achieved. That's all from me.